afternoon, everyone.
Good afternoon, sir.
Good afternoon. Good afternoon. So, what we were doing yesterday? So, we defined continuity and we did a result also, that sequential criteria for continuity, right? So, today we will do some examples of continuous functions. Okay. So, let us first again revise the definition of continuity. Okay. Let us quickly revise it. So, what is a function? Let A be a subset of R. Let A be some subset of R, F be a function from A to R, and C belong to A, be any point. Okay. The function, so the function F is said to be the function F is said to be continuous on at point A, at point C, if for each epsilon greater than 0 there exists some delta greater than 0 such that mod of fx minus fc is less than epsilon whenever your x minus c is less than delta and your x belongs to the domain. Okay, so the function is continuous at some point c if for each epsilon greater than 0 there exists delta greater than 0 such that fx minus fc is less than epsilon whenever x minus c is less than delta. So we have seen what we, so then we observed that f is continuous at point c belonging to a if one of the following holds. So क्या दो चीजें थी? First,
अगर C cluster point है और
C is not, yes, if C is not a cluster point, so then in this case so it trivially holds. And second,
अगर cluster point है तो limiting value function के value के बराबर.
yes, C is the cluster point of A and limit x tends to C fx is equal to fc. So ये fact याद रखना कि f is continuous at some point C belong to A if and only one of the following holds. C is a cluster point is, so either C is not a cluster point of A, और अगर cluster point होता है तो वहाँ पे limiting value should be equal to the value of the function. Okay. So then we did sequential criteria. Yes, what was sequential criteria? F is continuous at C if and only if for every sequence xn in A with xn converging to C, the corresponding sequence
fxn converges to fc.
Yes, fxn converges to fc. So this was our sequential criteria, that f is continuous at C if and only for every sequence xn in A with xn converging to C, the corresponding sequence fxn converges to fc. Now we have divergence criteria for this. So divergence criteria क्या होना चाहिए?
सर एक ऐसा सीक्वेंस मिलना चाहिए an में जो कि C पे कन्वर्ट करे बट f of x and f of c पे ना कन्वर्ट करे.
सर लगता है आप म्यूट हो गए.
No, I was not muted. I was there was some connection error, so I somehow I got disconnected. So I'm back. Am I audible?
Yes, sir.
Yes, sir.
Okay. Okay, fine. So we were defining this. So divergence criteria. What is this? That if we have some subset A of R, f is a function from A to R, C is some point in A, then f is discontinuous at point C belonging to A if and only क्या होगा if and only if one of the following holds.
There exists a sequence.
If and only one of the following holds. So first is there exists a sequence xn in A with xn converging to C, but fxn does not converge to fc. So basically what is happening is that your fxn might be converging, but it is not converging to f of c. So in this case fxn is converging, okay, but it might not converge to f of c. Now second is that this fxn does not converge at all. So उस case में क्या होगा, we will be able to find, so there exist two sequences xn and yn in A, both converging to C, but their corresponding sequence converges to different limits. ठीक है? That is limit n tends to infinity fxn is not equal to limit n tends to infinity f of yn. So इस केस में भी जो है the function is discontinuous at point C. ठीक है? Is it fine?
Yes, sir.
Yes.
So हम इन दोनों में से कोई भी क्राइटेरिया यूज कर सकते हैं to prove our theorem. Then we have one more definition. So continuity on a set. सेट पे कंटिन्यूस कब बोलेंगे? अभी तो पॉइंट पे बात कर रहे हैं, हमने एक पॉइंट पे डिफाइन करा है कंटिन्यूटी. तो सेट पे कंटिन्यूटी क्या होगी? यस. So what should be the continuity at some set? अगर हमें सेट पे कंटिन्यूटी बोलना है तो the function should be continuous at every point of that set. Yes, the function should be continuous at every point of that set. ठीक है? So as you can see in hello. Yes. Good afternoon. Okay. So you have some set contained in R and f is a function from A to R. B is some subset of A, and we say that f is continuous on the set B if f is continuous at every point of B. So अगर हमें कहीं भी continuity दिखानी है किसी भी set पे, तो we will have to show the continuity at every point of that set. That is, अगर हमें question होता है कि prove that the function is continuous at this on this set, so we will take any arbitrary point of that set and then we will prove the continuity at that point. Okay. So let us do some examples. So first is the constant function is continuous on R. So how you will prove this?
सर सीक्वेंस ले लेंगे xn is equal to c और फिर c minus c हमेशा
continuous on R. नहीं अगर प्रूव करना है सीक्वेंशियल क्राइटेरिया से, तो देन यू विल हैव टू पिक आर्बिट्री सीक्वेंस, क्योंकि प्रूव करना है ना हमें. लेट So simple है इसका proof, हमने पहले करा भी हुआ है. Let fx equal to b for all x belonging to R be any constant function. Okay, and now let c belonging to R be any arbitrary point, because we have to show continuity on the whole set R, so we will pick any arbitrary point. So let c belonging to R be any arbitrary point in R. So we have picked any arbitrary point. Now we will show f is continuous at, so claim f is continuous at C. So simple, दो तरह से कर सकते हैं, या तो you can use epsilon delta definition, or what you can do is you can use sequential criteria. So let xn be any sequence in R with xn converging to C. Now for all n belonging to n, what is f of xn?
B.
F of xn is equal to B, right? So what does this imply?
F of xn converges to B. Sequence f of xn.
Yeah, so this implies f of xn is a constant sequence. Yes, it is a constant sequence. या सीधे बस ये लिख भी सकते हैं हम, converging to B. So by sequential criteria for continuity, f is continuous at C. Since C belonging to R is any arbitrary point, it follows that f is continuous on R. Fine. So इस तरह से लिख सकते हो. You take any arbitrary sequence that converges to C, then corresponding sequence is a constant sequence which converges to B. So by sequential criteria, f is continuous at C. Okay, let us take the next example. The function fx equal to x for every x in R is continuous on R. So how you will prove this?
सर इसमें भी कोई सीक्वेंस ले लेंगे.
Yes, let xn be any sequence in R with x. अच्छा पहले arbitrary point लेना पड़ेगा ना. First we have to take any arbitrary point, right? First we have to take some arbitrary point. So let C belong to R be any point. So we picked any arbitrary point. Now we will show, so claim f is continuous at C. So this is what we have to show. So for this we pick any arbitrary sequence. Let xn be any sequence in R with xn converging to C. Now f of xn क्या होगा?
xn
is equal to xn for every n in n. So this implies f of xn is nothing but the sequence xn and which converges to C. So by sequential, अच्छा this is equal to f of C. ये तो important है. We forgot to write this here also. This is equal to f of C because we have to show that f xn converges to f of C. ठीक है, so ये दिखाना important है. So ये लिखना important है. This is important. So f of xn converges to f of C. So by sequential criteria for continuity, f is continuous at C. Again, since C belonging to R is arbitrary, it follows that f is continuous on R. Yes, let us take the next example. So what should we take? x square.
Sir, can you please show previous slide?
Okay, this one.
Yes, sir.
Yes, so we started with any sequence. We started because we have to show that f is continuous on this whole set R. So we started with any point in R. Okay, then we wanted to prove that f is continuous at C. So we were going through sequential criteria. So we picked any arbitrary sequence that converges to C. So now the corresponding sequence fxn is nothing but the same sequence xn, because fxn is equal to xn for every n. So fxn is the same sequence xn and which converges to C, and C happens to be the value of the function f at C. So by sequential criteria for continuity, f is continuous at C. Okay? Is it fine?
Okay, sir. Yes, sir.
Okay. So now let us take another example, your x square. So same way you can prove it. The function fx equal to x square is, अगर epsilon delta definition से पूछ लिया तो then you will have to do using the जो हमने लिमिट में करा था उस तरह का पूरा करना पड़ेगा, डेल्टा निकालना पड़ेगा. ठीक है? So basically you have to show that limit x tends to c, x square is equal to c square. This we have already done. ठीक है, epsilon delta definition से. So अगर एग्जाम में पूछ लिया कि epsilon you prove using epsilon delta definition, then you will have to apply that. So it's continuous on R. So again proof. So let C belong to R be any point. Okay. Claim.
Say epsilon delta sync.
Okay. Claim f is continuous at C, that is to show limit x tends to C, f of x equal to f of C, that is limit x tends to C, x square is equal to C square. So consider, so let epsilon greater than, because if we want to prove by epsilon delta definition, so we have to start with any arbitrary epsilon. So we let epsilon greater than 0 be arbitrary real number. So we have started with any arbitrary real number. Now we have to find some delta. So उसके लिए क्या करेंगे हम? So consider fx minus fc, right? क्योंकि हमें fx minus fc को x minus c की फॉर्म में लाना है, k times x minus c. So fx minus fc, so this happens to be your x square minus c square. Now you can apply the a plus b, a minus b formula. So this is x minus c, x plus c. So by triangle inequality, this is less than equal to x plus c. Sorry, triangle नहीं, अभी तो बस ये bracket लगाया है. ये तो, in fact, this is equal. They both are equal. And now we use triangle inequality. So this is mod c. Now because x is in numerator, okay, so we can use any bound on x minus c. अगर डिनोमिनेटर में होता तो c के टर्म्स में बाउंड लेना होता, बट अगर वो न्यूमरेटर में x, तो we can use any real number as a bound. So let x minus c be less than 1. So this implies mod x is less than 1 plus mod c by reverse triangle inequality. ठीक है? Fine. So using in double star, we have, using star we have, so using double star in star we get fx minus fc is less than 1 plus mod c, 1 plus 2c हो जाएगा क्योंकि already there is 1 mod c, 2 mod c, x minus c. So what delta we should choose?
Minimum of 1,
So
epsilon upon 1 plus 2 mod c.
Minimum of 1 epsilon upon 1 plus 2 mod c. Then clearly by the choice of delta, mod fx minus fc is less than epsilon, whenever mod x minus c is less than delta. Hence, by definition of limit continuity, f is continuous at c. Now since c belonging to R is any arbitrary point, it follows that f is continuous on R. ठीक है, सो सेम बिल्कुल बिल्कुल कुछ भी चेंज नहीं होगा, जो हमने लिमिट में चीजें करी हैं बिल्कुल। अगर एप्सिलॉन डेल्टा डेफिनेशन से पूछ लिया तो एल की जगह बस एफ सी है, बाकी सब तो पूरा का पूरा सेम है, ठीक है ना। बस हमें क्या शो करना होगा, एल की जगह एफ सी लेके हमें शो करना होगा। सो एल की जगह बस एफ सी लेके करना है, बाकी पूरा सेम है। ओके, इज इट फाइन? सो जो हमने लिमिट्स में करा था, अगर एप्सिलॉन डेल्टा डेफिनेशन से पूछ लेते हैं तो बिल्कुल सेम चीज करनी है। इफ यू कैन सी, हमने कुछ भी अलग नहीं करा है यहाँ पे, बस हमने एल की जगह वी आर यूजिंग एफ सी, बाकी सब तो सेम है, ठीक है। इज इट फाइन?
Yes,
Yes,
sir.
sir.
ओके, next question is this. Show that the function fx equal to 1 by x if x is not equal to 0, ठीक है। So there are two ways in which this can be asked. अगर खाली ये फंक्शन डिफाइन करके दे देते हैं, if they give you this function and if then they will ask you to prove that x is the function is not continuous at 0, तो क्या करना होगा?
सर सीक्वेंशियल क्राइटेरिया, डाइवर्जेंस
नहीं नहीं
क्राइटेरिया।
नहीं 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 नहीं, नो नो नो। अगर हमें ये फंक्शन दिया है जो मैंने अभी लिखा हुआ है, if I am given this function, then you will say f is not continuous at c because f is not continuous at 0 because 0 is not in the domain of f. f is not defined at 0, ठीक है।
सर वो तो x नॉट इक्वल टू 0 पहले ही कंडीशन दे दिया है ना।
हाँ हाँ, वही तो मैं समझा रहा हूँ। इफ यू आर बीइंग आस्क्ड टू शो दैट द फंक्शन, दिस फंक्शन, अगर ये क्वेश्चन दे दिया इज नॉट कंटिन्यूअस एट 0, तो f of 0 तो तुम्हारी बात ही नहीं कर सकते ना, यू कैन नॉट टॉक ऑफ f of 0, राइट, बिकॉज f of 0 इज नॉट डिफाइंड। सो वो उसकी बात ही नहीं कर सकते। सो यू विल डायरेक्टली से दैट द फंक्शन इज नॉट कंटिन्यूअस एट 0 बिकॉज इट इज नॉट डिफाइंड एट 0, 0 इज नॉट इन द डोमेन ऑफ f, ठीक है।
Yes, sir.
ठीक है, ये ध्यान रखना इसका, ये दो तरह से आ सकता है। अभी मैं दूसरा तरह का इसका भी कराऊंगा दूसरा। There are two ways in which this question can be asked. So this is more simpler. You just have to write that since f is not defined at 0, so f is not continuous at 0. Simple, ठीक है, इतना से लिखना है। You don't, इसमें ये मत दिखाना कि sequential criteria, क्योंकि ठीक है ये नहीं दिखा सकते बिकॉज यू कैन नॉट टॉक ऑफ दिस। एफ ऑफ 0 पे बात तो तभी करोगे ना जब ये डिफाइंड होगा। सो ये डिफाइंड ही नहीं है, इसलिए यू विल नॉट टॉक ऑफ दिस सीक्वेंशियल क्राइटेरिया कुछ भी, बस सीधे ये लिखोगे दैट एफ इज नॉट डिफाइंड एट 0 बिकॉज सो एफ इज नॉट कंटिन्यूअस एट 0, ठीक है। बट इफ दिस क्वेश्चन इज आस्क्ड लाइक दिस, so they might define it at 0, तो डिफाइन करने के लिए कुछ भी रियल नंबर दे सकते हैं, ठीक है। क्वेश्चन show that the function fx equal to 1 by x, x not equal to 0 and any real number they can might take, ठीक है। यहाँ पे 0 भी ले सकते हैं, कुछ भी रियल नंबर, कुछ भी डिफाइन करेंगे तब भी नहीं डिफाइन होगा। is not x equal to 0, so इस फिर क्या करना होगा, So now it is defined at 0. So now you will have to take either sequential criteria, जो भी criteria लेना है, then you will have to take that. Okay. So अगर sequential criteria use करना है तो you will have to give a sequence that converges to 0, but its corresponding sequence does not converge to a, f of 0, which is a. So क्या करोगे, कौन सा sequential criteria use करना है तो what you will take with sequence?
1 by n.
1 by n. So let xn equal to 1 by n for all n belonging to n. Then xn converges to 0 and f of xn is equal to n for every n belonging to n. So this implies f of xn is an unbounded sequence, right? And hence not convergent, because every convergent sequence is bounded and hence not convergent. Thus, by divergence criteria, for discontinuity, ठीक है, f is not continuous at C. ठीक है. So remember this thing. अगर तुम्हें ये इस तरह से पूछ लिया, then you will have to show. अगर ये तुम्हें इस तरह से पूछ लिया तो then you will simply have, because you cannot talk of continuity at point 0 because f is not defined at 0. ठीक है. So इसलिए यहाँ पे इस तरह से बोलना है और यहाँ पे you have to say, इसको यहाँ पे प्रूव करके दिखाना है. Is it fine?
Yes, sir.
Okay, and if you are asked to show that one, और बाकी अगर ये क्वेश्चन आ जाता है कि show that the function fx equal to 1 by x is a continuous on A, which is the set of all real numbers, set of all positive real numbers, then it is defined on this domain, right? So how you will prove it?
क्लेम कर लेंगे कि 1 by x 1 by c पे कन्वर्ज करेगा, फिर एप्सिलॉन डेल्टा.
तो या तो हम एप्सिलॉन डेल्टा से डेफिनेशन से कर सकते हैं, उसमें हमें ये शो करना होगा लिमिट x टेंड्स टू c 1 by x इक्वल टू 1 by c, ये हम ऑलरेडी कर चुके हैं, राइट? सो एप्सिलॉन डेल्टा डेफिनेशन से ये प्रूव कर सकते हो. और दूसरा क्या है, you can use sequential criteria. Sequential criteria में you will take any arbitrary sequence 1 by xn, वो xn converging to c, तो 1 by xn will converge to 1 by c. ठीक है, by algebra of limits, algebra of
Yes.
sequential limits. ठीक है, उससे भी आ सकता है. So कोई भी एप्सिलॉन डेल्टा से करना ज्यादा बेटर रहेगा. ठीक है, मतलब इजी उससे है, बट क्योंकि हम ज्यादा अभी एप्सिलॉन डेल्टा पे फोकस है तो उससे करना इसको ज्यादा वो रहेगा. सो यू विल पिक एनी आर्बिट्री पॉइंट इन A. So let C belong to A be any arbitrary point. So C is greater than 0. Okay. So then claim F is continuous at C, that is limit x tends to c, f of x is equal to f of c, that is you have to show limit x tends to c 1 by x is equal to 1 by c. So then you can repeat the proof of that. So क्या था वहां पे, कैसे करते थे हम? We start with, so let epsilon greater than 0 be any real number, then we consider fx minus
Mod
fc,
of
right?
1
Right?
upon x minus 1 by c.
Yes. So this is nothing but mod of 1 by x minus 1 by c. So this is 1 by xc mod x minus c. So this is equal to 1 by mod x, 1 by mod c, x minus c. Now because our x is in the denominator, so what bound we shall take?
C by 2.
c by 2. c is positive, so इसलिए mod नहीं लगा रहे हैं, वहां पे हमने mod लगाया हुआ c by 2. So then यहाँ से क्या आएगा हमारे पास? So then c by 2 is less than x less than 3c by 2. अब क्योंकि हमें डिनोमिनेटर में रिप्लेस करना है, तो we will replace by a smaller number so that the number will increase. Okay. So this is star, this is double star. So using double star in star, we get mod fx minus fc is less than, ये क्या हो गया, 2 by c square. 2 by c square x minus c. X minus c is less than c by 2. ठीक है. So let delta क्या लेंगे? Minimum of c by 2 and epsilon c square by 2. Then by the choice of delta, mod fx minus fc is less than epsilon whenever x minus c is less than delta. Hence, by definition of continuity, so by definition of continuity, f is continuous at c, and that since c is any arbitrary real number, since c is belonging to a is arbitrary, it follows that f is continuous at on a. ठीक है. So अच्छा, एक चीज मैं बताऊं, जब भी when you are trying to practice this all these questions, तो हमेशा प्रूफ को पूरा लिखो. Every step should be complete. उससे क्या फायदा होता है? You get the habit of writing the complete proof. So एग्जाम में तुम्हें फिर लिखने में दिक्कत नहीं आएगी. If you can see, I am still, अब मैं तो तुम्हें बता रहा हूँ और ये चीजें हम ऑलरेडी कर चुके हैं, but still I am writing the complete proof. So इससे एक ये मतलब तुम्हें जो है एग्जाम के लिए अच्छी प्रैक्टिस हो जाएगी. वहां पे यू विल नॉट मेक अ मिस्टेक. ठीक है, वहां पे सोचना नहीं पड़ेगा कि नेक्स्ट स्टेप क्या होगा, नेक्स्ट स्टेप क्या होगा. इट विल बिकम अ हैबिट, और राइटिंग भी अच्छी हो जाएगी तुम्हारी. मैथमेटिक्स को राइट वो करना, वो तुम्हारा अच्छा हो जाएगा. ठीक है. सो जब भी प्रैक्टिस करते हो, ट्राई दैट प्रूफ को प्रॉपरली लिख रहे हो, ऐसे स्किप नहीं करना कि चलो हो गया. ठीक है. सो राइट एवरी स्टेप हर एक क्वेश्चन के लिए. ठीक है. So let us take the next question. So अभी तक हमने ये सब कर दिया, 1 by x कर दिया. Now we will take Dirichlet function. So क्या था Dirichlet function? Basic Dirichlet function क्या था?
तो दो केस होते हैं, x या फिर irrational हो और rational हो.
हाँ. So let us define some function. So Dirichlet type problems. तो सेम जो हमने कंटिन्यू वहां पे लिमिट्स में करा था, वही चीज यहाँ पे भी होगी. ठीक है, कुछ डिफरेंट नहीं होगा. सो क्वेश्चन, शो दैट द फंक्शन fx equal to 1 if x is rational and 0 otherwise, that is x is irrational, is discontinuous everywhere on R. हर एक पॉइंट पे डिसकंटिन्यूस है. So कैसे प्रूफ आएगा इसका, बताओ.
सर एक सीक्वेंस मान लेंगे.
नहीं, पहले तो यू विल पिक एनी आर्बिट्री पॉइंट ना, तुम्हें क्योंकि शो करना है कि हर एक रियल नंबर पे इट इज डिसकंटिन्यूस. सो ये फर्स्ट यू विल पिक एनी आर्बिट्री पॉइंट. सो लेट C belong to R. be any arbitrary point. Then what next?
सर रेशनल और इरेशनल में एक सीक्वेंस एग्जिस्ट करेगा जो कि सी पे कन्वर्ट करेगा.
Yes, by density theorem we know that there exists sequence xn in Q and yn in Q complement such that xn converges to C and yn also converges to C. So we have two sequences, एक rationals के एक irrationals के, both converging to C. So this is by density theorem. What next? Now f of xn is equal to, because xn is rational पे value 1 है, so f of xn is equal to 1 and f of yn is rational, so it is 0 for every n in n. So f of xn is a constant sequence 1 and f of yn is a constant sequence 0. So clearly f of xn converges to 0 and f of yn, sorry,
that converges to
उल्टा लिख दिया मैंने, f of xn converges to 1 and f of yn converges to 0. So we have two sequences, so thus we have two sequences xn, yn and yn both converging to C, but their corresponding sequences are converging to different limits, right? So by divergence criteria for discontinuity, f is not continuous at C. So again, as C belonging to R is arbitrary, so it follows that f is discontinuous everywhere on R. ठीक है, so we are just repeating what we did in our limit portion. ठीक है, बस उसी को रिपीट कर रहे हैं, बस अब कंटिन्यूटी के टर्म्स में कर रहे हैं. तो वो चैप्टर आ गया तो तुम्हें आधा ये चैप्टर आ जाएगा. ठीक है, सो मेक श्योर यू प्रैक्टिस चैप्टर 4 प्रॉपरली सो दैट ये आगे का पूरा कंटेंट बहुत इजी हो जाएगा तुम्हारे लिए. ठीक है, इज इट फाइन?
Yes, sir.
yes.
Okay, now what about this function? Let fx equal to x if x belongs to Q and 0 if x does not belongs to Q. So कहाँ पे continuous होगा?
C equal to 0.
Yes, show that f is continuous only at x equal to 0. ठीक है, so जहां पे भी इक्वल होंगे उसी पॉइंट पे कंटिन्यूस होता है, बाकी कहीं नहीं होगा. So let us try to write its proof. So same way में प्रूव करेंगे, वही चीजें हैं बिल्कुल. So how we proceed for this?
Let C belongs to R.
Then
दो केसेस बना लेंगे.
case 1,
Yes.
पहले C not equal to 0.
C is equal to 0 या C not equal to 0 ले लेते हैं. चलो, then
फिर दो सीक्वेंस होंगी
yes
जो
same,
कि C पे कन्वर्ट कर रही
yes
होंगी.
बिल्कुल सेम यही चीज आ जाएगी.
अलग अलग लिमिट होगी तो फिर डाइवर्जेंट हो जाएगी.
Yes, right. क्या हो गया? Okay, so that's C not equal to 0. So this is by density theorem, you will have two sequences. We know that there exists sequence xn in Q and y in Q complement such that both converges to C. So now what will happen?
f of x and c पे कन्वर्ज करेगा.
Yes. Okay. So now f of what will be f of xn? F of xn will be your
xn.
xn. Okay, so f of xn is equal to xn and xn converges to
1.
C, and f of in is equal to 0, so which is not equal to C. So both are converging to different limits. Okay. Is it fine? So बिल्कुल same proof आ जाएगा. Okay, are converging to different limits. So by this is there. Now you will take the case 2 when C is equal to 0. So now यहाँ पे हमें continuous show करना है. Frame f is continuous at 0. So क्या करोगे यहाँ पे फिर? You start with any epsilon. So let epsilon greater than 0 be any real number. So what will be consider? कैसे करते हैं? fx minus f0. So this is
Yes.
so ये क्या हो जाएगा? This will be equal to
mod fx.
mod fx, right? Because f0 is 0. f0 is 0, so this will become mod fx या mod fx minus 0 लिख देते हैं पहले एक स्टेप में. So which is equal to mod fx, and mod fx क्या हो जाएगा? Less than
सर
equal to
जीरो, सर
mod
जीरो
x.
भी रेशनल है तो यस सर.
हाँ तो 0 रैशनल है तो वहां पे 0 आ गया ना.
यस सर, हो गया सर. एक्स.
ठीक है. सो ये और ये जो mod fx है ये हमने देखा ये कि या तो ये x हो सकता है या 0 हो सकता है, तो दोनों mod x से तो छोटा वही छोटा ही होगा या बराबर होगा mod x के. ठीक है ना. सो इसलिए हमारे पास ये इनइक्वालिटी है बाय डेफिनेशन ऑफ fx. ठीक है. एंड दिस इज सो लेट डेल्टा इक्वल टू एप्सिलॉन, then by the choice of delta it is evident that fx minus f0 is less than epsilon whenever x minus 0 is less than delta. Hence by definition of continuity, f is continuous at 0. So we are just repeating the proof of what we did in वो limits. So कोई भी क्वेश्चन आ सकता है. ठीक है. वो सेम ही चीज करनी है, हमें कुछ अलग नहीं करना है. अब एक अभी कितना. ओके सो वी आर लेफ्ट विद नो टाइम. एक क्वेश्चन है जो बहुत ही इंपॉर्टेंट है, मतलब बहुत इंटरेस्टिंग भी है. इट इज डिफरेंट फ्रॉम ऑल दिस. उसे थॉमस फंक्शन कहते हैं. इसकी कंटिन्यूटी चेक करके आना कैसे प्रूव करनी है, फिर हम कल करेंगे इसको, बट अभी एक बस लेट मी जस्ट राइट द स्टेटमेंट ऑफ दिस from function. So this is very interesting function. Okay, so fx is defined like this. So it is defined on positive real numbers f from so definition f is a function from r positive, okay, so I think r positive, yes, okay, so it is defined like this. R positive defined as fx equal to 1 by n, okay, 1 by n where क्या होगा if x belongs to q, और जब भी कोई रैशनल नंबर होता है तो it is of the form and x is equal to m by n where GCD of mn is 1. ठीक है, is it fine? So रैशनल पे इस तरह से डिफाइंड है, रैशनल पे उसकी वैल्यू क्या आएगी, इट इज ऑफ द फॉर्म 1 by n, क्योंकि एवरी रैशनल नंबर इज एक्सप्रेसिबल इन द फॉर्म ऑफ दिस, राइट, m by n के फॉर्म का होता है. सो हमारे पास ये आ जाएगा और इससे फिर हम 1 by n ले लेंगे एंड इट इज 0 इफ x does not belongs to q, that is x is rational, रैशनल पे 0 और रैशनल पे 1 by n और इरैशनल पे 0. So show that the function f is continuous only at the set of irrationals. ठीक है, बस पे कंटिन्यूस है, रैशनल पे डिसकंटिन्यूस है. इसको ट्राई करना, हाउ यू विल प्रूव दिस, बुक से पढ़ के जैसे भी ट्राई करना, ठीक है. So it will take some time, so we are not doing it today, okay, and we will do it tomorrow. Fine?
Okay, sir.
But try करना, but try करना, because if you will try then you will know कि हम जो क्लास में कर रहे हैं वहाँ पे क्या डिफरेंस है, ठीक है. So you will come to know, otherwise थोड़ा समझने में डिफिकल्ट भी हो सकता है. It is a slightly difficult problem, थोड़ा there are tricks, so just make sure that you try this, चाहे बुक से पढ़ के करो कैसे भी करो, just try to prove it, ठीक है. इसको ट्राई करो प्रूव करने की. So then अगर नहीं भी होता है तुमसे तो then when we will do it in the class then you will know कि where we are what trick we are using and why that trick we are using, ठीक है. So all those things you will come to know only when you have tried it, otherwise लगेगा कि क्यों कर रहे हैं ये सारी चीजें, ठीक है. So just give a try to this function.
Okay, sir.
Okay, so this much is enough for today. Anyone wants to ask any question? Okay, so as there are no questions, let us end this class then. Okay, so now we meet tomorrow. So bye everyone, have a good day.
Thank you, sir.